So this is question 1II of same year, same on limits, past question 223/224. Evaluate the limit as x tends to 0 of root 9 plus x and minus 3 over x. So solution, we have the limit as s tends to 0 of root 9 plus x minus 3 over x. So what we have to do in this case, x is tending to 0, so we have to substitute x equal to 0 to this expression. And if we substitute x equal to 0, we'll be having root 9 plus 0 minus 3 over 0. So this is going to give us an indeterminate solution. So in this case, the limit must not give us an indeterminate solution. So what we'll further do is to deduce this limit in such a way that it will give us a result. Alright, it will give us a result. The limit must not give you an indeterminate solution. So either of this case, you either use L'Hopital's rule, the H method, or the conjugate method. Alright, so in this case, I'm going to be taking the conjugate of this limit in order for me to deduce it and get a solution. So if I have the limit as x tends to 0 of root 9 plus x minus 3 over x. Alright, so if I take conjugates, if I take conjugates of this, I'll have to handle this. Then I'll multiply both the denominator and the numerator by this. But here I will later turn to a positive sign. So what that means is that I'll be having the limit as x tends to 0 of root 9 plus x minus 3 times. Alright, so this is root 9 plus x plus 3. Alright, so you notice that in taking conjugates, the sign here will change. So I'll be having all over x times the root of this 9 plus x plus 9 plus s plus 3. Alright, so this plus 3 is outside the root sign here. So I'll be having the limit as x tends to 0. The limit as x tends to 0, I'll be having this times this will give me root 9 plus x squared. This times this will give me plus 3 root 9 plus x. Alright, plus 3 root 9 plus x. Then this times this will give me minus 3 root 9 plus x. So I have this times this will give me minus 9. Then all over, I have this times this to give me x root 9 plus x, then plus 3 here. Right, so if you see very well, this and this can cancel out. So I'm left with, you also see that this is a root sign and this is a square. So this can cancel out this. So I'm left with the limit as x tends to 0 of 9 plus x, then minus 9 over x root 9 plus x plus 3. Right, so this is what I have. This is what I have here. So you see very well that this and this can also cancel out. Let me just rewrite this to have 9 plus x minus 9 here, all over x root 9 plus x, then plus 3. This is what I have. So you see very well that this is 9 and this is 9. So 9 and 9 can cancel out. So I'm still left with the limit as x tends to 0 of x over x root 9 plus x, then plus 3. Alright, so x can also cancel out x here. So I'm left with the limit as x tends to 0 of 1 over root 9 plus x plus 3. So in this case now I've deduced the function from this point here. I've deduced this from this point down to this point. So I can now substitute the value of x, which is 0. I can now substitute x equal to 0 because x is tending to 0 here. So I'll be having 1 over 9, that's root 9 plus 0, then plus 3. So this is my answer here. This is 9 plus 0, which is 9. So I'll be having 1 over root 9 plus 3, which will give me 1 over root 9 here gives me 3, then plus 3 gives me 1 over 6. So it means that the limit as x tends to 0 of root 9 plus x minus 3 over x is equal to 1 over 6. That's the answer.